just going to practice finding critical values algebraically, and then we'll check the graph to see if they're turning points. Turning points mean the function turns direction. It switches from either increase to decrease or the other way around, decrease to increase, which means those are possible maxes and mins. All right, so and we'll look at those graphically for right now. So first problem I'm going to do is a polynomial example. All right, so there's a polynomial example, finding critical values, and then checking the graph. All right, so first thing, critical values are when the derivative, so again, remember the critical value is when the derivative is 0 or does not exist, so the first thing you have to do is find the derivative. Switch from my right pen to my blue pen. Alright, so find critical values, which means find the derivative. Alright, so the derivative of a polynomial is pretty straightforward. Power rule, constant rule. Alright, so I get 4x cubed here. The 3 will multiply by the 8/3, so the 3's will reduce. Leave me with negative 8, x to the second. The 2 will zero out. Alright, so there's my derivative. It's a polynomial, so it exists everywhere. So the does not exist case does not apply. So there's no special, corners or vertical tangents. The only possibility is having a horizontal tangent case. Alright, so now I set it equal to 0, and that's a key step. You have to show that in the show your work. Set it equal to 0 and solve. Alright, so take the function's derivative, set it equal to 0. So 4x cubed minus 8x squared. And most of the time, these are going to be factorable, meaning I'm going to factor it. Now this one actually is, sometimes these easy factor cases throw students off. It's an easy factor case because all that you're going to factor out is the greatest common factor. If you look at this, the 4x cubed and the negative 8x squared, I can pull a 4 out of both terms, right? And I can pull 2 x values out of both terms. And so that's what I'm going to do. Alright, still set equal to 0, so I'm going to factor a 4 out and an x squared out. Well, then what am I left with? Well, that 4's gone. I pulled it out. I pulled 2 of those out. I still had 1 left over. Remember, pulling them out means dividing. So out of the 8, I divided out the 4, which means I had a 2, right? When I take 8 divided by 4, there's a 2 left over. And then I pulled out both x squared, so that's gone. And so what's left over inside is the x minus 2. Alright, now I use the reason why we factor is because the next rule we're going to use is the zero factor property, which means all of my factors that contain x values give me zeros. So my x squared gives me a 0, and my x2 can give me a 0. Well, the square root of 0 is 0, and there's no plus or minus on it. So one critical value is 0, and then this one I moved the 2 over. And so the other critical value. So those are my critical values. My critical points, which again, the y value comes from the original f of x function. So this original function back up here. So my original f of x was x to the 4th minus 8/3 x cubed plus 2. And so to find the y value, I take 0 and plug it into my function. I take 2 and plug it into my function. Alright, so when I take 0, 0 is easy. It's just going to leave me with 2. 2 is a little harder. I plug it in, and it comes out 3.33333 repeating. And so I'm going to hit my fraction key to get exactly negative 10/3. Alright, so there are my critical points. My critical points on my original function are at 0, 2, and at 2, negative 10/3. Alright, there's my critical points. So there's the answer to the first question. Now the second part is see if they're turning points. See if there are places where I have changes in increase and decrease, which will be possible maxes and mins. And so we're going to graph the original, graph the f of x. Standard windows should be fine, and I kind of know a standard window is fine because if I look at my critical moments, all of my values land between 10 and negative 10. None of them are bigger than 10, and none of them are smaller than negative 10. So you can hit zoom standard on your calculator, so when you do that, you'll hit, if it's not in a standard 10 by 10 window, hit zoom and then standard window. Right, if you do that, it should graph on your calculator and give you this looking shape. Alright, so there's the graph of f of x. And then I'm going to mark off my critical values. All right, so remember, I know my critical values are at 0, 2. So that would be this moment here. That's that sort of S shape where it does have a horizontal tangent there. At that 0, 2 spot, the function stops. So if this was cost, or actually it's decreasing, so if this was like a profit function or something, well, profit was decreasing, stopped at this moment, decreasing, didn't increase, but stopped. But then after that moment, it started to decrease again. So it didn't switch direction, so it's not a turning point. Then the second point would be this one at 2, and you can check it on your graph. Hit the value key, so hit second trace value, type 2, and it should give you that negative 3.333 repeating. Alright, so this is a critical moment. I do have a horizontal tangent, so at both those moments I have horizontal tangents. They're both critical moments, but only the 2 negative 10/3 is a relative, in this case I can see it's a relative minimum. The other one is just a critical moment. It's just a stopping point. It's neither a max nor a min. Right, it's that special sort of S-shaped case. Alright, so there's a polynomial example. So I'm going to pick up in the next, so I did the polynomial example. I believe the next example is a root example. So we'll do that in the next one, next video.